Okay, we're going to look at something called the quadratic formula. And so we're going to start by saying we want to solve this following quadratic equation for all possible values of x. Before we get into that, I want to say let's think of this as a graph for a second, a parabola. So I'm going to write this as y equals. And let's take a look at that graph. I think I have it here. All right, so there's a look at that graph. There we go, I like that better. All right, so we're thinking about that. Now, let's say we want to find the x-intercepts. To find the x-intercepts, we plug in 0 for y, and then we solve. So we arrive at this equation here. So if we want to solve this quadratic, we know that, okay, it's in standard form. I've got x squared and I've got x, so I can't isolate the x because I have both the quadratic term and the linear term. So I have to factor it, set equal to 0 and factor. So my a is 1 and my c is 1, so I'm looking for factors of 1. So that's just going to be 1 and 1. That's what multiplies to 1. So factors of 1. And also -1 and -1. Now I need to look which ones add to the middle term, right here, the -6. Well, none of them do. So we can't factor this, all right? But clearly, if you look at the graph on the right, there are x-intercepts, but we can't factor this. So we cannot solve this for x. We cannot find what x makes y 0. And that's because if you look down here, or not because, but what's happening here is, let me just grab this guy. All right, so we're looking down here. Not every quadratic is factorable, okay? Sometimes when it isn't factorable, we can use a square root method to solve it, but that's only if it's in this form. So we're not worried about that. We're worried about standard form right now, okay? So if it's not factorable, but there's clearly still solutions, because if we look over here at the graph to our right, we see that there's x-intercepts. So sometimes factoring doesn't work, and then how do we solve a quadratic in that occasion? And we have this formula, the quadratic formula. So here's a quadratic in standard form, okay? And the formula, it looks a little crazy, but it's going to use the a, the b, and the c. And to find your x values that make y 0, you're going to do -b plus or minus b squared minus 4ac all over 2a. That formula will find your x-intercepts, or will solve the quadratic. So if you have a quadratic equaling 0, that's the key, standard form equaling 0, you can use this formula to find the x's that make the y equal to 0. And on a graph, that would be like the x's of the y-intercept. So let's take a second here and look at what these values are. Those are our x-intercepts. Notice they're decimals to 3 decimal places. That's because they're irrational numbers. Those decimals actually never end and never repeat. So clearly, we're not going to be able to find those through factoring, okay? But those will be the solutions, all right? So those are the numbers that multiply, are factors of 1, but then will add up to 6, or in this case, sorry, -6. So, yeah, let me just make sure. Yeah, okay. So let's go ahead and do that, right? So let's use our formula here to come up with those decimals. So using the quadratic formula, solve the equation from exercise 1. So here's the same one. So first thing you should do is identify a is 1, b is -6, and c is +1. Whoops, let's write that a little more neatly, right? A, B, and C. So the formula is, I recommend you write it down each time you use it. Oh my gosh. This is freaking out. X equals negative b plus or minus the square root of b squared minus 4ac. Okay, let's try that again. Minus 4ac all over 2a. All right, so I'm going to zoom in here. So our x is negative b, so b was negative 6, so I'm going to put it in parentheses. That's negative b plus or minus the square root of b squared, so negative 6 squared. Whenever you square a negative, you better put it in parentheses. Minus 4 times a, which is 1, and c, which is 1. Remember, I pulled those out over here. All over, it's supposed to be over 2a. All over 2 times a, which is 1. Now, the first thing we should deal with is, what is this plus or minus? What does that mean? Well, remember, there could be up to 2 x-intercepts, so you need 2 solutions. So really, it's just a fancy way. They didn't want to write all this over and over again, like twice, so they just combine it into 1. But I'm going to separate it right away. So we have 6 plus, remember, minus a negative is 6. I'm going to start simplifying. I'll start simplifying. Negative 6 squared is 36, minus 4 times 1 times 1 is just 4, all over 2 times 1 is 2. I guess I didn't need that long of a square root. All right, so that's one solution. The other solution is the same formula, but this time I use a minus. So 6, because the minus a negative, minus the square root of negative 6 squared is 36, minus 4, all over 2. All right, so I've got 6 plus. Now I'm going to simplify inside the square root. 36 minus 4 is 32, all over 2. Or it could be x equals 6 minus 36 minus 4 is 32. All right, so now the square root of 32, well, 32 is not a perfect square, so this will end up being a decimal. The square root of 32 is about, I'll call it 5.657. So x equals 6 plus 5.657 all over 2. Or x can be equal to 6 minus 5.657 all over 2. So if I continue to simplify, 6 plus that number, so we're going to go 6 plus 5.657 is 11.657, all divided by 2, or x equals 6 minus 5.657. Whoops. I'll get rid of this stuff here. And I get 0.343, all divided by 2. So my final two answers are 11.657 divided by 2, which is about 5.826, we'll call it, when I round. And then let's do the other one. It's going to be 0.343 divided by 2, and we get x equals 0.172, we'll call it. Those are our two solutions, which will be our two x-intercepts. Let's check those again. 5.828 and 0.172, so there's some rounding depending on when you round, but they're close enough, right? So that's how you do that, right? That's how you can solve if it's not factorable. You have to use this formula. Having said that, you can remember these are irrational numbers, so you can get the decimal approximation through those steps, or you can simplify and leave as an exact value by taking these right here and simplifying these numbers. So I'm not going to simplify this one. We'll work on simplifying on a later example. All right? So let's just move on and try a different example. Which of the following represents the solutions to the equation? All right, so we have this equation, x squared minus 10x equals negative 20. All right, so if we want to solve for x, since I have x squared and x in the same equation, you can't just isolate x. I can't get x by itself. Some students will try to do that. When you have the x squared and the x, you do the opposite of isolate the variable. You don't get x's on one side and numbers on the other side. You bring everything to one side and you zero it out. So I've got two terms over here and one term on two terms on the left side and one term on the right side. If I divide it into sides, right? So what I want to do is, instead of trying to separate x's and numbers, when you have the x squared and the x, bring everything to one side. So it's easier to move this one term over here. So I'm going to add 20 to both sides. Over here they cancel and I get 0, and that's the goal. We want to zero out that one side of the equal sign. Let me erase that dotted line so I can move this up a little. So I get 0 on the right side, and on the left side, I can't add 20 to either one of these, so I'm just going to write it at the end, plus 20. All right, so now we have a standard, we have a quadratic in standard form, and I would try to factor it using FOTAT. So A is 1 and C is 20, so 1 times 20 is 20. So I'm looking for numbers that are factors of 20. So I have like 1 and 20, 2 and 10, 4 and 5. I think that's all of them. And then they're negative versions. So let's add these together and see which ones add up to negative 10. I get 21, I get 12, and I get 9. So none of those add to 10. Therefore, if I make all their pairs negative, they're not going to add up to negative 10. So this one is not factorable. So you should always try to factor first. But this one is not factorable, so we have to use the quadratic formula. So remember, A is 1, B is negative 10, and C is 20. So now our quadratic formula, let me get some more room here, is negative B, so negative 10, plus or minus, and I'm going to keep it as one formula this time. I'm not going to separate it. I'll show you what happens. We don't have to separate till a little later. Plus or minus the square root of B squared, so negative 10 squared, minus 4 times A times C, all over 2A. So now let's start simplifying before we separate it into two equations. Minus a negative 10 just becomes a positive 10, plus or minus. Inside the square root, I am going to square the 10 first, so the negative 10. So negative times a negative is a positive, and 10 times 10 is 100. Minus, I don't know if it's minus or plus actually. I'm going to look at this part. I have three things times each other. A negative times a positive, that will be a negative. Now I do 4 times 1 is 4, and 4 times 20 is 80. All over, let me get rid of this. All over 2 times 1. All right, so then next step in simplifying, I got 10 plus or minus. I'm going to do the 100 minus the 80. I'm simplifying under the square root here. So 100 minus 80 is 20, all over 2. And now 20 is not, we can't square root 20, right? I could try. I should have left that over there, I guess. Right, I could try to square root 20, but I get a decimal. And our goal on this one is to find the exact value, not the approximation. Even this decimal here that Desmos is giving me is an approximation. This decimal goes on forever and never repeats. So I'm going to try to simplify this expression and basically leave it as it is. So if you can't square root 20 and get an integer, and that's what I mean by can't square root 20, okay, and get an integer value like a 4 or a 5 or something like that, maybe you can break 20 down, the square root of 20 down into numbers that you can, numbers that you can square root. So let's think about numbers that multiply to 20. I could do square root of 10 times the square root of 2. Can I square root either one of those though? Like, do they have a perfect, are they perfect squares? Square root of 10 is a decimal, no, darn. Square root of 2, decimal, darn. So those don't work. Those numbers do multiply to 20, but they don't help me simplify. I'm looking for two numbers that multiply to 20. I did not want to bring that over there. I'm looking for two numbers that multiply to 20 that at least one of them can square root. So what are two other numbers that multiply to 20? How about 4 and 5? Since I can't square root 20, maybe I can break it down into two numbers times each other where I can at least square root one of them. So how about the square root of 4 and the square root of 5? Oh yeah, I could square root the 4. Square root of 4 is 2 times the square root of 5 all over 2. All right? Now, I'm done simplifying the square root. That's how you simplify a square root. I should check the square root of 5 and see, can I break that up into two more numbers times each other that I could square root one of them? And the only option is 5 and 1. And of course, I could square root 1 and call it just a regular 1. But then 1 times square root of 5 is just square root of 5, and I didn't get anywhere. So I want to break it down into numbers where I can square root at least one of them. 5 doesn't work. So this is simplified as far as it can be. I want to show you that this number, square root of 20, is the same as 2 times square root of 5. Look over here at the calculator. Square root of 20 is that decimal, and 2 times the square root of 5 is that same decimal. Those two numbers are equivalent, so we're just simplifying it, breaking it down to the smallest possible square root. So again, I couldn't square root 20, so I tried to look for two numbers that multiply to 20 that at least I could square root one of them, and I found it. And that's how you simplify a square root. All right? Now from here, I want to divide by 2. But because of, I keep doing that, because of the addition and subtraction here, it has two terms up top. You can't just divide 2 into this or 2 into that. You can only divide the 2 if it divides into both parts, which it does. 2 divides into 2 once, and it divides into 10 5 times, and it divides into 2 once. So you divide the 2 into both parts. That's the only time that you can do that. You can't divide it if it only divides into 1. So then the simplified version is, let me use my purple here, 5 plus or minus square root of 5 all over 1. Of course, I don't have to show divided by 1, so 5 plus or minus the square root of 5. Now remember, that's really two answers, so now I would separate it just so I can see the two solutions. 5 plus square root of 5, and x can also be 5 minus square root of 5. So you can write your answer like that. Excuse me. You could write your answer like this. Just understand that that means two different answers. You could write your answer like this. I'd accept any of these. You can make a list. This is if you're just solving for x. Any one of those is acceptable way to write your answers. All right? So that's how you do the quadratic formula, and that is how you simplify a square root. I'm going to stop here. I don't want this video to be too long. We'll do exercise 4 and 5 in class.